Good afternoon, everyone. On behalf of BMS School of Architecture, Yelahanka, Bangalore, I warmly welcome you all to Research Dialogue 17. It's an ongoing academic initiative of BMSSA aimed at fostering critical inquiry and research or interdisciplinary exchange and research culture within the institution and outside. Under the visionary leadership of our director, Dr. Shaila Bantanur, we continue to strengthen platforms that enable meaningful engagement between academia, practice, and research. The Research Dialogue series is conceived as a space for rigorous discussion, emerging ideas, and reflective scholarship in architecture, urbanism, and allied fields. It is our privilege today to introduce our distinguished resource person, Dr. Faiz Ahmed Chundeli, Assistant Professor at the School of Planning and Architecture, Vijayawada. Dr. Faiz engages with digital urbanism, computational modeling, sustainable habitat systems, building energy performance, and urban climate responsiveness. His research bridges architecture planning and environmental analytics, bringing together data driven approaches with sustainable design thinking. With extensive academic experience, research leadership roles, and involvement in national and international projects, including urban resilience initiatives, he brings valuable insights into contemporary directions in built environment research. We are delighted to have him with us today and look forward towards an engaging and intellectually enriching session. Our director herself has a session today, so once she finishes that, she'll be joining us and would be welcoming you formally. Meanwhile, I think we can start with the presentation. Over to you, sir.
Okay, thank you so much for the introduction. And first of all, thanks for the invitation. What I'll do is, although you have shared the audience profile, I have until I know the audience's interest or understanding of the subject, it will be difficult for me to balance where how much depth I can go. So what I'll do is I'll put up the slides and discuss what is the subject, and then I'll just show one case study which we have very recently done. In fact, we had just submitted yesterday the final project report on the topic of discussion today. So if there are any further questions or clarifications, maybe probably you can interrupt in between, or we can have the discussion at the end.
Yeah. Our participants can also put in their questions in the chat box. That helps. And sir, we have quite a few students also undergraduate from the profile that I sent you before. I think in the last couple of hours, a lot of undergraduate students have also joined in. They just wanted to be a part of the session, so we might have that as well. So please go ahead. We'll see as and when we find questions in the chat box.
Yeah. Thank you. Thank you. The screen is visible and it's working.
Yeah. Yes, it is.
Okay, thank you so much. Yeah. So the topic that is put forth is to understand how. Just one second. Yeah. So outdoor thermal comfort, modeling and measurement. So I have divided the discussion in three parts. First, we'll try to understand what is outdoor thermal comfort or thermal comfort as such. I'll not discuss much about modeling and measurement. I'll explain this using the case study that I'll present later. So the session I have conceptualized like this. Probably will take about 10-15 minutes to discuss what is outdoor thermal comfort. I have just simplified it to keep focused. We'll just discuss only 6 key points about outdoor thermal comfort. Which is required, which is kind of, we can say that this is essential. There are many other things. There will be many other things, but I'm just highlighting these 6 components, which is very, very essential in order to conduct or to do some work on this line. And in the second part, I'll take you through one of the case studies on cooling strategies for Hyderabad, what we have done on this. and what is the approach that we can have, and whatever we try to learn in the theory, how do we apply that into practice or research, and how not only in terms of uh, practice, how do you convert that into policy, how we can work with the local government also. So that's the intention of my presentation. I hope I'll be able to. I hope I do justification for this. Okay, fine. So the first point, first part of the discussion, let's keep it very brief. The 6 key points essential for understanding outdoor thermal comfort. So the first, of course, the first question will be on what is thermal comfort? What is the definition that that is widely there, and what is acceptable, and what is the common definition that we adapt when it comes to thermal comfort. So if you see uh, and also excuse me, I have some cold issues as well. Maybe I may be coughing in between. Excuse me for that. Uh,
Same
uh,
here, sir. Everywhere, everyone has code. Don't worry, sir.
yeah. So the first thing is what is comfort and how do we define comfort? One of the common definition that is adapted or discussed in the on this subject is to adapt ASHRAE standard or ASHRAE 55 standard, which says the condition of mind which expresses satisfaction with the thermal environment, and this is and it is assessed by subjective evaluation. Okay, so it is kind of a situation where we feel comfortable, and it the definition says it can be measured using subjective evaluation, subjective measures. We'll see what is subjective measurement and what else are added to this definition to make it more scientific. Okay, so let's keep this definition in mind. Now, if you go into further details, it also gives how do you measure it? So they put the definition under under the certain parameters for 6 parameters which defines comfort. Okay, so on the first line they said comfort can be it's how we feel, but how do you define it in terms of variables? If you go into further details, they say that the comfort can be uh, measured using environmental parameters and personal factors. And they specify 4 parameters, which is ambient air temperature, mean radiant temperature, of course, the wind speed and relative humidity. So 4 environmental parameters and 2 personal factors, for example, clothing and metabolic activity. So all these 6 components define are used to define comfort in a given condition, and people will respond to the surveys or the measurements we take. It's all subject to how these parameters behave in mind. Okay, so the first thing that we should remember, there are 6 variables, 6 parameters, which can help us in which can help in defining how do we define comfort as such. 4 environmental parameters and 2 personal uh, personal factors, which means how much we are clothed and what kind of activities we do. First thing, point number 1. Point number 2. So if that is the comfort definition of comfort, what is the definition of outdoor thermal comfort? We are adding one more word here for the definition. So outdoor thermal comfort is affected by the outdoor environment. Okay, and the outdoor thermal environment is significantly impacted by how we design the built form. So now it's not only the environmental parameters that we discussed last slide and 2 personal parameters that it is there in the definition. Now we are adding the built component into it, into the definition. Okay, so all these 4 plus 2 plus 1 is analyzed together to understand how outdoor thermal comfort can be described. Okay, this is point number 2. Now, if you go into further details, there are again, like we have discussed for thermal comfort, Outdoor thermal comfort also, there are several studies, hundreds of studies have been done to categorize how do we put all these parameters in certain categories. So, if, for example, let's say these are personal parameters, and then all that can be clubbed into physical, physiological, and psychological parameters. And under physical, for example, let's say the same thing that we discussed under comfort. Air temperature, radiation, humidity, and so on. And in physiological uh, parameters, our body mass index, skin temperature, and so on can be taken into consideration. And psychological parameters, experiences. For example, let's say I'm visiting this place for the first time. So my expectations are different. Or maybe, for example, let's say I visit a temple. So my expectations are different in that environment than somebody who's there for a long time. So experiences, expectations, and all that will also have an implication on uh, how somebody feel comfortable or not. Okay, so this is point number 2. Now we have discussed what is thermal comfort and what is outdoor thermal comfort, and there are several variables. You can say that 6+1 variables are required for us to understand or define how thermal comfort can be established or studied. Okay, now how do we evaluate? What are the indexes, or what is the metrics available for assessing comfort? So this is another question that we have to understand before we get into the actual subject itself. How do you measure it in simple terms? Okay, these are parameters, individual parameters that we have, but collectively, how do you say that this is good, not good, comfortable, not comfortable? What is the metrics available? So that brings us to point number 3, different indices for understanding both thermal comfort or outdoor thermal comfort, both it comes into picture. If you actually see the literature, there are hundreds of indices available for measuring comfort, both in both indoor and outdoor comfort. So of all the hundreds of indices available, there are 3 indices which are most commonly used that I have put up in the slide. One is PMV PPD model, and uh, probably those who are working on this line or studying something about comfort, you must have come across this predicted mean vote and predicted percentage dissatisfaction, PMV PPD model. Primarily, this has been used in indoor conditions, and later, in some cases, it has been used in outdoor conditions as well. But relatively now in the recent literatures, this has not been done. We don't use these PMV PPD as much as has been used earlier. Oh, the second parameter, which is second index, which is commonly used, is called PET, physiological equivalent temperature. This is one of the very commonly used metrics for measuring comfort. So, for example, let's say a PET value, how you will get to know, it's all measured in degrees Celsius. And if, for example, let's say if you get a value of 2930, it means warm, and physiologically it means moderate heat stress. Okay, so I'll not get into details of this. Maybe if required, we can have a separate session or separate talk to describe this. So PET has been normalized. This is a standard PET values, but it has been normalized for different climatic conditions. For example, let's say in India, probably warm and humid conditions. So, for example, the same 2930, here is comfortable in case of warm and humid. It may not be comfortable in, let's say, cold climate. Okay, so PET is one of the index or one of the metrics most commonly used to understand or to define comfort condition. Okay, this is the second index. The third index, which is also very commonly used, is UTCI. It's been more familiar, more commonly used in the recent publications. Apart from apart from air temperature, humidity, wind speed, and metabolic rate, all that, it also accounts into the behavioral factors and so on. So the UTCA index is more commonly used, or you can say that this has been recently in last 5-10 years. This has been more commonly used. Okay, so we have three indexes, of which PMVPPD is not that much used. PET is one of the metrics, and UTCA is another metric that will be commonly used. Okay, this is point number 3. Now, okay, these are metrics, but how does this metric work, and what goes into this metrics is also something that we have to know. So I have put that how these metrics are developed, what goes into each of the metrics can again be a subject of study and investigation. I have just put here very simply so that we have some brief understanding of what this metrics is all about. For example, let's say we can measure comfort only using temperature and humidity. Okay, heat index. Sometimes it's called heat index. And our National Building Code talks about tropical summer index, which takes into consideration of your wet bulb temperature into consideration. So each metrics is measured in a different way. Okay, so some of it may consider only temperature, wind speed, and relative humidity. Some may consider other parameters as well. Okay, so this structure is also we need to understand. So if you go into further details, we can put this measurement in two categories. One is objective driven, the other one is subjective driven. So let's go back to the first slide where we said thermal comfort can be established, or thermal comfort studies can be assessed using subjective evaluation, meaning we ask only the questions like we take surveys and then we ask certain standardized question to understand how subjectively somebody defines comfort. Okay, no measurement is involved. Okay, this is one parameter used in the metrics. The second parameter, which is which makes the this kind of study more interesting, is inclusion of objective parameters. What are objective parameters? Where we can measure it. Temperature, we can measure it. Wind speed, we can measure it. Relative humidity, we can measure it. So we have instruments, modeling techniques to do all this. So some of the matrices are developed only using subjective evaluation, but the PET and UTCA that we are talking about combines both in all combines both in the sense in order to be more correct in our assessment, both subjective and objective evaluation is necessary. Okay, so the metrics should involve the kind of metrics that we use should have objective assessment and also subjective assessment. Okay, so if you go into details, for example, let's say we have SET, PET values. These are the values in which all these things recordings are done. Again, this is also something that we need to have understanding on before we actually start applying this in real-time case. Okay, that's point number 4. What goes into defining of metrics. Now, point number 5, thermal sensation word. Many times what happens is, if you also see the definition, it says subjective evaluation. So many times we ask only questions and then we try to stop there. Okay, that's only one half of the assessment. It's called subjective assessment, or you can say that qualitative assessment, thermal sensation word. So PET can be for example, let's say you can measure temperature, but you cannot ask somebody what do you think 23 degrees Celsius is about. They may not be saying that I'm comfortable at 35 degrees Celsius. They may not say that at 40 I feel hot. Okay, they will people will respond like this. I feel hot. I feel uncomfortable. So the objective measurement and subjective measurement should be taken together to understand this and then take it further. Okay, so this is the fifth point. Let's not focus only on qualitative aspect. It has to be clubbed with quantitative aspect. How do we do quantitative aspects? That brings us to the last point. Instruments for measuring or conducting this kind of outdoor thermal comfort study. There are several instruments. For example, for measuring air temperature, for measuring wind speed, for measuring globe temperature, for measuring humidity. There are several instruments available. These instruments can be used to collect objective data of a particular situation, and that can be that has to be seen in line with the qualitative data that we have collected to come to some conclusions that whether those spaces are comfortable, not comfortable, to what extent these parameters have an impact on. Okay, so these are the 6 parameters which I feel is very much essential in order to do any kind of work, any kind of research work in these lines. Okay, uh, uh, these are some simple sentences. Yeah. Is there any question?
Hi. Kindly switch off your mic, please. Kindly mute yourself. Give me a second. Give me a second.
Yeah. Okay, so these are the 6 points that I have put up that is essential for us to move further. I have not gone into details because without these, it will be very, very difficult for us to move further. Okay, so I have just given some references here, which you can, if somebody is interested, you can take it up or take it up as a course itself. We have put up a NPTEL course. It was funded by British Council. It's called Climate Resilient, Energy Secure, Healthy Built Environment. The course was developed jointly by University of Bath, IIT Roorkee, and SP Vijayawada also involved. Several institutions were part of it. So we have discussed how the urban climate can be understood, how urban geometry have an impact on comfort, and how do we measure urban geometry, and the further details on outdoor thermal comfort and how we can go about it. And at the end of the day, why we are doing it and how is it impacting the overall performance of the urban fabric. If somebody is interested, you can take up these courses, and that will give you more detailed theoretical perspective of what is the subject and what are things that is needed for us to have an understanding on, so that we can apply this in real-time case. Okay, so that's the first part of my presentation, where I've tried to very briefly tell you what is outdoor thermal comfort and how do we measure it. Okay, so if you have not got anything for last 10-15 minutes, still I would say there are only 2 or 3 essential parameters that we should remember. One is, how do you define it? What are the variables that is required for defining comfort, outdoor thermal comfort? And how do you measure it? That's more important. How do we measure it is more important. If we have clarity on that, probably we'll be able to take it and apply in real-time case. Okay, now let us say that we have some understanding of how these comfort metrics work. And if you apply on real-time case, how do you do it? What is the process? And how do we get the results? And how do we interpret the results? That's another part of the story, right? So I'll just say, again, this is also not going to be a very detailed, in-depth presentation. 45 minutes I'll take. In that 45 minutes, I'll try to explain how we can take this, how we can conduct this kind of studies. Okay, this is one of the project funded by Ministry of Housing and Urban Affairs, where we had proposed how do we cool down, what are the strategies available for cooling city of Hyderabad, so to say. Okay, so we are calling it as urban heterogeneity and microclimate, local climate zone-based approach. Um, uh, for arriving at possible cooling strategies. Okay, so here I'll just very briefly take you through some background why this subject is relevant in case of Hyderabad. What is the objective that we have set, and what is the method that we followed, and how do we arrive at hotspots, and how do we from hotspots, how do you get into the neighborhood level scale, something like this. And then what kind of strategies can be applied there uh, so that the first of all assess what is the condition like, and also apply some strategies to check whether we can improve the thermal conditions. And for the case of Hyderabad, how we have arrived at results. Okay, so what is the background? Like many cities in India, Hyderabad is also has grown significantly. 400% of built up has been seen since 1970, and Hyderabad also has seen frequent summers touching 40, 44 as well. Okay, and this has been consistent. Nighttime temperature has been consistently, at least during the summer months. It has been recorded that the summers have been very severe qualitatively. Now, if you put that into quantitatively and check historically whether this argument is supported by historical data, um, we have plotted the temperature from 1970s to 2024. If you actually see by absolute number, there is only some fraction of increase in absolute air temperature. So we can say that it's not much. If you compare the temperature in 1970 and in 2025, the absolute number is increase is very fractional. But where is the anomaly happening? The anomaly is happening in the summer months. You can see the extended summer months. Of course, winter also has gone in some of the years. The extended winters can also be felt. Extended summer months has been observed. Okay, now this is for 1 year data. You can say 8760 hours of data, just to understand how temperature and humidity for the case of Hyderabad is. So we have a comfort band here. The red line is, of course, the mean value, and the band that you see is the comfort band, actually comfort band, where 80% or 90% acceptability is there. And you can see that in several days and several months, the temperature increases beyond the comfort range. This has been the case in several cities as well. One thing that we also forget is we don't look at humidity part, especially when in the warm and humid conditions, and even in a composite climate like um, Hyderabad as well, we have to look at the other parameter, humidity as well. Humidity is also a cause of concern for Hyderabad, particularly during the summer months. You can see that the humidity levels are going below 30% as well, which is also not good. We normally talk about temperature, we forget about humidity. Humidity is also something that will have a profound impact on comfort and also on energy consumption and so on as well. Okay, so this is the perspective. This is a closer look looking up of summer months, March, April, May, June, and you can see the comfort band is somewhere here. Throughout the summer months, the temperature is of course exceeding the comfort band throughout the month, at least for these 4 months. And also humidity level as well, you can see it goes below 30, and which is also a cause of concern, particularly during the summer months. So keeping this into perspective, how do we set the objective? What was the objective of this project? The objective of the project was to develop evidence-based implementable canopy layer UHI mitigation strategies. I'll explain you what is canopy layer UHI strategies in coming slides. So the objective is to come out with strategies that can help in balancing the heat that is accumulating in the city of Hyderabad. You can put it in that simple way. The methodology followed: identification of hotspot, classification of local climate zone, and then identification of specific strategies, how it can be done. Translating these strategies into implementable projects is what we had tried to do it. So how do we proceed on the subject? The first step is to first identify how heat is formed or heat accumulation is happening in the cities, and how we can map UHIs, urban heat islands, and how do we map the hotspots of the city. One of the commonly used technique is to take out Landsat data, which gives surface temperature, and to understand how heat accumulation happens. Okay, most of the time we restrict our discussion only to Landsat, which gives surface temperature assessment during the daytime. We had included MODIS data, which gives nighttime temperature profile as well, so that we have a comprehensive understanding of how heat accumulation is happening during the daytime and also during the nighttime. So we had done time series analysis from 2024 to 2024, how built-up has changed, how green cover has changed. As a result, how land surface temperature has changed, and how UHI mitigation, how UHI islands are being formed. Okay, so just for pausing, how do you read this map? We have this is 2004 data, and this is 2024 data. This is Hyderabad Greater Municipal Corporation, GHMC. And you can see that in 2004, the UHI values are less. You can see the UHI intensities more than 2-degree difference. You can hardly see. But after 10 years of assessment, you can see there are accumulation of heat happening across the city. And also in 2024, you can see a similar pattern or increasing pattern in heat accumulation for the time period. So this Landsat data gives only information during the daytime. We wanted to check what happens during the night time as well. So for that purpose, we took MODIS data, which gives which takes the image of the city in the night time as well, when you can process it. So we have a data here: 2004 10 a.m., 2004 1 p.m., 2004 10 p.m., 2004 1 a.m. Similarly, we have the data set for 2004, 14, and 24. Just for discussion, you can see what happens during the in the morning hours of 2024 at 10 a.m. You can see the surface temperatures of about 40-45 degree can be observed. This is during the month of May. Can be observed in the peripheries of the city, and the city is still the surface temperature is of about 35 to 40 degrees Celsius. In the afternoon, the surface temperature goes beyond 45 degrees Celsius, and you can see it's spread across the city. What happens during the nighttime? The heat, you can see the accumulation of heat is there still. And at the night, late night or early morning, 1 a.m., you can see the peripherals of the city, the heat has been exhausted. But in the core city, the heat is still being retained. The heat is still there. Okay, that's what we call it as heat islands. The heat remains there despite um, not availability of sun. Okay, one thing that you can see here, I have put up a section taking somewhere here. We have a big lake here. People who are familiar with Hyderabad, Hyderabad, this is Hussain Sagar Lake, one of the biggest lake there, right? So if you have taken the sections and put here how temperature variation happens if you take it through the section, this is the lake. So you can see how during the daytime, the surface temperatures are very less, obviously, right? It requires no explanation. The water has the capacity to accumulate heat, and it can take up a lot of heat. Okay, once the sun is not there, okay, you can see at night 10 p.m. the peripherals are starting to cool. However, the water that has been heating up during the daytime starts emitting heat back into the environment. Okay, so what we need to understand is apart from building, we should also have an understanding on what happens to the water component, what happens to the green component, how they behave as well. Okay, most of the time what happens is greens and blues are suggested as strategies for cooling. So it may not be so in all cases. We have to check in which case greens are going to be effective, in which cases blues are going to be effective. Okay, this is also we should remember. Okay, now I've said, I'm sorry. So I have said we have taken the data for daytime and also taken the data for nighttime. Daytime Landsat data, nighttime Moody's data. Both are surface temperatures. Actually, these are satellite-based information. If you see recent the literatures, in addition to surface temperature, we also need air temperature to assess the UHI or heat accumulation in real-time perspective. So we had we had accessed the authorities, and when for our study, we had taken about 17 weather station data from Hyderabad. There are about 155 weather stations within the city of Hyderabad. And I think people who are involved in this kind of research also, they may not be aware that such data is available. Okay, many times what we do is we just take IMD data and we just take one weather station and then we try to analyze. But actually, if you go into depths, I'm sure in Bangalore must be there. So if somebody is working on Bangalore, and you should check whether you have automatic weather station data, local weather stations, so that your study becomes more realistic and grounded if you have access to these data set. So we purchased about 17 weather station data to make our study more realistic. So these are temperature, humidity of the real-time data. So now we have UHI formation using air temperature, UHI formation during the nighttime, Moody's data, UHI formation using Landsat data during nighttime. Keeping this in mind, we identified hotspots. The different hotspots are, and in order to take the study further and come out with specific solutions, we identified one of the wards. Primarily, it's called Madhapur, and we went on to do further investigations on how specific strategies can be arrived, keeping this in mind. So in order to do that exercise, uh, uh, we could have start study here and gave a proposal for the entire city itself. Okay, but recent studies have suggested that this is a very generic approach. It does not work in most of the cases. So we need more in-depth, finer assessment at micro level as well in order to arrive at specific strategies for cooling. So we adapted a technique called local climate zone, and also to arrive at UHA mitigation, that canopy layer. So what is a canopy layer? For example, let's say if this is the entire city, and normally UHI is done for this entire city. We just say that what is the rural context and what is the urban context, what is the temperature difference between rural and urban. We call that as UHI UHIs. But if you actually see further details of the urban built fabric, if you see a street of where something like this, a street, narrow street, something like this, and we have a built up area of such nature, these urban components will behave differently. For example, if you see the overall here, this urban component is different from this urban component naturally, right? So a strategy which fits into this dense urban area should be different from a strategy that fits into a less dense urban fabric. Okay, so this leads to specific strategies that can be worked out, keeping the urban morphology into mind. And again, this is not something new. It has been very, very well established. A lot of work has been done and is being continuing to be done on this line. And there is very famous book on written by Oak, which where he says how we can identify climatically active surfaces, both for the building and also for the vegetation and also for the water bodies to understand how these components interact with one another and how heat accumulation or dissipation happens. And one of the way forward is to arrive at local climate zones. For example, let's say this is a typical, this is an from the literature. So if this is the city, uh, each city fabric will have different urban characteristics, and they will behave differently. So we need specific strategy for all of these cases. For example, let's say I'll just go back to the slide. I've taken a section I put up here. You can see this. This is a section taken across the city, and this is temperature, surface temperature, and if you see horizontally, different urban characteristics, green and blue characteristics, presence of because of these presence, you can see variations in surface temperature. If the if the values have been stayed something like this, then we can have one strategy because it's all same. We can one strategy may work, but you can see variations, ups and downs because of the urban characteristics. These the heat accumulation also varies, and therefore we need specific interventions. These dips are actually water bodies. This is how this is what happens during the daytime if you have water body in this case. So keeping this in mind, we went ahead to identify local climate zones for Hyderabad, and also recent studies have suggested that these kind of zone specific strategies are more effective than pan city strategies. Uh, so we did classification of LCZ for Hyderabad. And for those who are not familiar with what is LCZ, LCZ is local climate zone. It divides the city into different urban fabrics of climate zones. So for example, how it does, there are about 10 classes of building. Building is not one building, right? So building has certain characteristics when we look at from the climate perspective. So a compact high-rise building will behave differently from a compact mid-rise building. So like this, there are 10 typologies of built fabric, 4 typologies of green fabric, 2 typologies of soil or barren land, and 1 water body. So keeping this in mind, keeping these factors into mind, the local climate zones are classified. In further, for example, let's say if I say this local climate zone is 1, LCZ1, I also agreed that that has a sky view factor of this much, canyon ratio of this much, mean building height of this range, terrain roughness class of this range, impervious surface fraction of this much, and also it has an anthropogenic heat, meaning let's say the emission factor of this factor, this much. Okay, so using this classification, we can divide the city into different climate zones. We have done that exercise. This again, this is a scientific exercise. There are different tools available to do that, and based on our classification, we found that Hyderabad has LCZ2 and LCZ3 as a primary. Predominantly, these are the types of building fabrics that is available. What in terms of reading, compact mid-rise and compact low-rise are the predominant built structure that we can find in Hyderabad case. So in order to do further studies, we went on and we identified about 17 neighborhoods where we can do further modeling and then come out with specific interventions for that. So, for example, let's say this is one of the neighborhoods that we have identified, and where 2D data, 3D data has been collected, and then this has been modeled for outdoor thermal comfort assessment. So these are different about 17 neighborhoods that we have taken. I'll just skip through this. Okay. Now, how do we arrive at strategies? Okay, so now I've said that we have identified area for study, and then parallelly what we did was we took best practices from across the world. How for a specific city, for example, let's say a similar composite climate situated cities, what kind of best practices are available and how we can, what kind of strategies that we can take out and then apply and test it in case of Hyderabad to see whether these strategies work in case of Hyderabad or not. So these strategies are put under 4 heads. One, with respect to the greeneries. When we say green, it can be green roof, green wall, street trees, roadside vegetation, or urban pocket, urban green. And we also used blue infrastructure. When we say blue, it is water bodies and other streams and river. But in our case, since it was very urban specific intervention, we also tried to check whether fountains and mist systems can help in case of Hyderabad. Why? If you recall the slides that I showed on temperature and humidity, during the summer months, the humidity is very low. It's a dry condition. So we need humidification to happen during the summer months. So we tried to bring in some interventions that can help in increasing the humidity levels for the city. Third intervention was to check how different surfaces for pavements, for walls, for roof can work. Cool roof, cool pavement, and cool walls. All that can be all we have tested. And in addition to this, if you add shading in urban areas, how shading can help, to what extent this can impact comfort in the urban areas. And this is since the city is already in existence, and many of these strategies are for mitigation, not for new layouts. So we also worked out in case of new layouts, how you can consider aspect ratio, sky view factor, building height, and so on and so forth, so that you have some control on outdoor comfort conditions. Okay, so how do we model it and how do we take it further? We use NVMet for simulation, and we also use instruments for further validation. We have a mobile weather station with us, so we have taken to these 17 neighborhoods just to record certain days of data to validate with the results that we are trying to simulate using NVMet model. So this is a representative model area for all the neighborhoods. Just an indication here. And this has been modeled in NVMet. The setup for the model has been presented here. And for those who don't know what is an what is NVMet and what it can give, NVMet can give NVMet can simulate at temperature, mean radiant temperature, relative humidity, temperature at 1.5 meters level, wind directions, solar radiations. There are about 40 to 45 parameters that can be simulated in NVMet model. So which also gives simulation of PMV, PPT, PET, UTCI values that I have put up in the slides earlier. So which means apart from since the focus is on outdoor thermal comfort, so I'm just restricting the discussion only to the comfort indexes. Otherwise, we can discuss on other parameters as well. NVMet gives these outputs as well. Okay, so this is just an indication of how NVMet results would look like. And like this, we have done for all 17 neighborhoods that we have identified. And then we had ran simulations for several hours, several days, and a lot of parameters has been generated. And we'll be discussing only one of the parameters, which is PET, as one of the measures for assessing comfort. So similarly, in addition to the buildings, we also studied on street level comfort conditions and recordings at center point, midpoint of the street, on either side of the street at different intervals has been taken. And several strategies have been worked out for streets as well, keeping these greeneries alongside the street, keeping the greeneries touching one another, keeping adding shading, changing the ground cover. There are several strategies that we have tested. So I'll just skip this. So to list what are the strategies that we had taken from literature and tested in Hyderabad. These are the 11 strategies that we have taken from across literature and also from the case studies to check. These are the strategies that has been applied and tested in other places. We can also use, or we can also test and see whether these strategies work in case of Hyderabad or not. So which include cool roof, cool pavement, cool walls, water bodies, checking the orientation, cool roof, cool pavement, microgreen, pocket green, whether if you have a neighborhood and if you have a neighborhood park, how much impact it is going to create. Cool pavement, does it help in comfort condition? Pervious pavements, what is the difference between the impact created by the cool pavement and the pervious pavement? And if you had green roofs and green walls, how is it going to work? And if you add just shading, temporary shading, how much benefit that we can extract? And of course, a lot of work on trees and different types of trees and combinations of trees have been done. Just ground cover, if you add ground cover, what is it going to do? And if you add shrubs, how much impact it is going to create? And if you add trees, and again, like landscape architects have several ideas for combining trees and so on and so forth. So how do you place that, and what is the impact that we can expect using vegetation is simulated here. So this is a graphical representation of how the simulations have been done. So what we did in the first place, we first simulated the existing case. That is a base case for us. So keeping the base case, we added, let's say, all the results are compared with the base case. Existing case, what is it? And if I just apply cool roof, how much variations it is bringing to the base case, whether it is helping the base case or aggravating the issues in the base case. So similarly, if I change cool payment, I compare it again with base case. By adding full payment, whether we are helping the base case or it is creating problem for us. So like this, all the case has been, all 11 plus strategies have been compared with base case to check which strategies are working and which is the most effective strategies. For example, let's say this is for one of the neighborhoods called IFPA Society, where how do you read this result? You have the base case on the first column, and you have the other parameters: cool roof, sorry, cool roof, plus cool payment, base case plus cool payment, base case plus pervious payment, base case plus green roof, orientation, change in orientation. This is a hypothetical, right? We can change the model and check whether if the street has been 90° like this, what is the impact it is going to create. So like this, we have put it here, and this has been compared with the base case. So what is the value here? This is all PET value comparison. So how do we read this? If you apply cool roof in this case, in this neighborhood, it gave a positive impact of about 0.16° improvement. And if you apply cool roof plus cool payment, it gave an PET improvement of about 0.35 degree PET value. However, if you apply only cool payment, it actually increased discomfort by about 0.1 degrees Celsius. Like this, all strategies have been compared, and then for each one is one simulation. Okay, base case is one simulation, cool roof is one simulation, cool roof plus cool payment is another simulation, and so on and so forth. Each simulations you can roughly take. It takes about 24 to 36 hours of simulation data to get that result. Okay, so like this, we have done for all the neighborhoods. You can see that if you apply these strategies, none of the strategies seems to be effective other than vegetation part. In fact, in some of the strategies are actually increasing more discomfort in these neighborhoods. And in some neighborhoods, we found that none of the strategies worked during the daytime. Okay, there could be several reasons for this. One reason could be our own modeling error, observation error. That could also be possible. But when we tested several times as well, we got a similar result. So which means to say that not all strategies are going to work the way we are expecting it to work. So we found a similar case in other neighborhoods as well, where actually the strategies the supposed to help in cooling has caused more problem than the existing case itself. Of course, in several other neighborhoods, we have got a lot of benefits as well. In fact, all strategies have worked in some cases. Significant improvement in comfort conditions in many of the neighborhoods were also observed. So like this, we did for all the neighborhoods. So what is the overall observation? The overall observation of the results, you can see here, vegetation. If you have only trees as one of your strategy, if you're talking only about PET value, you can see that the PET can improve the comfort condition by about 2.6 degrees Celsius, and it can improve your UTC value by about 2.5 degrees Celsius. Okay, and if you compare it with, let's say, if you're going only with ground cover and shrub, the results are positive but negligible. Okay, So like this, we'll we'll be able to we'll be able to understand and then suggest more scientifically whether these strategies will work or not. For example, let's say if you have trees, obviously the humidity levels are also increasing, and which is also a good point in case of Hyderabad, at least during the summer months. So this is for vegetation part. And if you look at the surfaces, cool pavements, cool roof, asphalt pavements, grass pavers, water retention pavements, cool coated asphalts and all. Although you may find some benefit in, for example, let's say if you're using red asphalt and grass pavers, PET value is actually improving, but you are actually increasing humidity, which is also good. But at the same time, you are increasing the relative humidity point. Not relative humidity, mean radiant temperature, which is kind of a cause of concern for us because it will have more radiant heat. So the cool, for example, let's say cool pavements, there may be improvement in PET value. There may be reduction in the surrounding air temperature, but your MRT is going to increase, which will indirectly have an impact on comfort condition. Okay, so these things also matters. We can't blankly or blanketly say that this is going to work, that is going to work. It has to be specific to the conditions that we are talking about. And when it comes to shading, shading gave a significant improvement in PET values, and also it has drastically reduced the mean radiant temperature, meaning radiations have been cut off. 13 degree is a significant number. So 13-degree reduction in MRT can be attained only by having temporary shades as well. So similarly, water we tried sprays and combination of shading, and this is water spray with trees, and this is the existing base case. So in both cases, the humidity value increased, and also shading and sprinkling of waters gave much better comfort condition during the summer months than spraying with having only tree. Okay, so which means shading, obviously, right? This is logical also. Shading is also complementing the comfort conditions here. So like this, we did all the assessment, and then we gave our recommendations like these are the strategies and how it can be applied on which aspect. What is the scientific mechanism that goes into the cooling component, and how much impact that we can expect in terms of, for example, let's say if you use cool roof, you can bring down your PET value from existing by about 2 to 4 degree difference. If you go only by air temperature, you can make a difference of about 1.5 degree Celsius in case of cool roofs and cool pavements and so on and so forth. But a significant improvement in case of both air temperature and PET value can be observed if you use trees, shrubs, and ground covers in combination as compared to other forms of intervention. And this is then we arrived neighborhood level metrics, which the local authorities can use. Now, maybe till here it's an academic exercise. Now, these things the decision makers don't understand whatever I have said so far. What they want is, okay, you have said this. What do you want us to do? From here they ask question, right? So what we did was we came with some specific strategies, what they can do in next 2 years time, or we call it as short-term strategy. Then some of the things can be taken up in as a medium-term strategy, 2 to 5 years, and some of it can be long-term strategies like pan city interventions. All can be at long-term intervention, both at neighborhood level as well at street level. Because state has to be looked at in as one element of urban, and it requires specific interventions for street and specific interventions for buildings. So for both, we try to give some suggestions. And then we also populated what kind of trees and shrubs can work in the case of Hyderabad, because not all vegetations are going to be useful. So it has to withstand the conditions there. So we populated that and then gave it. And then we also proposed some experimental work which they can try in this coming summer to check whether the proposal that we have put up is worth taking up. And if this works out, probably the city can implement in other areas as well. Later, one of the requirement was from the local authorities. How do we incorporate this into zoning regulations or building bylaws so that it can have a long-term infiltration? These strategies percolate down as regulations rather than just strategies, academic exercise or research exercise. So then we had suggested some modifications into the zoning regulations so that some of it can be taken as policy measures into the master plan. And we had closely worked with the proposals as well. Is there any question?
Please mute yourself.
Yeah, and we had tried to see how these strategies are in going along with the initiatives of the local government, so that our effort doesn't stop only as research work. It should be used by the local authorities. One last explanation before I conclude. During the process, there are several things that can be discussed. One thing, since architects will be there, architecture students are there, I would like to just highlight one component. Why it matters for us to select appropriate materials in our when we define comfort condition and also when we design buildings. Okay, so we have two buildings here. These are simulated buildings. One A is represented here. This is an apartment building, and B, this is a commercial building here. And we have some graphs here so that I'll explain it so that you all can follow what I'm trying to say here. So we have three lines here and three lines here indicating some values. What is this three line? The first line, which I'm drawing now, this is an indoor temperature of this building. And you can see here, this is an indoor temperature of this building. Okay, we will get into explanation in a minute's time. Now we have the second line, second graph line, which is this, which is outdoor air temperature. Same thing here, outdoor air temperature. And then we have a third line, which is like this. This is surface temperature of building. For example, let's say if you measure on top of this building, what is the temperature, surface temperature from 11 a.m. in the night to next day 11 a.m. Okay, so it is 24 hours plus data simulation. Okay, so how do we understand this? The outdoor air temperature is about 36 degrees Celsius, and it peaks about it goes up to 44 degrees Celsius, and then it again in the night it comes down to about 36 degrees Celsius. During early morning at 7, the temperature is about 32 degrees Celsius. Same thing happens in this building also because the context is same. There should not be any variations in outdoor temperature. It also has 36 degree Celsius here and about 32 degrees Celsius in the early morning. And it reaches to about 42 degrees Celsius in the afternoon. And in the night, again, it has a similar range, a fractional change in the temperature profile. Surface temperature also, since it is closer, okay, you can see the surface temperature during the night time is about 28 degrees Celsius. Here also it is about 28 degrees Celsius. Surface temperature reaches to about 50 degree plus in the afternoon time. You can see the surface temperature reaches about 56 degrees Celsius in the afternoon. Similar context, same thing has to happen. Now, what is the change here? Why am I discussing this here? The major change is the choice of material that these two buildings have. For example, let's say this is an apartment building. It has a standard window wall ratio, and it is made of brick of this thickness. The windows of this thickness, and it is the window wall ratio is very well within the 30% limit. However, on this building, you can see these are all glass curtain walls. The entire structural glazing has been used. The entire facade has been exposed to sun directly. Now, what is the implication it is going to create? Although the glass used here is about 6 mm double glass, whereas in this building it is only 3 mm glass. Okay, so you see the difference here. The indoor temperature, let's say at 7 a.m. it's 9 a.m. about 28 degrees Celsius. At 9 a.m. you can see the indoor temperature is about 34 degrees Celsius. Okay, what happens? The temperature raises in this building, and it goes to a peak of about 34 degrees Celsius in the evening. Okay, so the building gets heated up, and maximum temperature, indoor temperature, it reaches to about 36 degrees Celsius in the in the evenings of about 7 or 8 p.m. What happens here? You can see that this building also the indoor temperature raises, but it reaches about 40 degrees Celsius. This is higher side, and when it reaches 36 degrees Celsius, it reaches about 36 degrees Celsius early in the morning itself. At 9:10 itself, the indoor temperature is about 36 degrees Celsius, whereas this building it took about 7-8 hours more to reach 36 degrees Celsius. Okay, so that's the difference that we are going to make if you consciously make material choices. Despite being this double glaze on all that, it's the choice of material matters not only for outdoor conditions, it also matters heavily for how the building is going to perform as well. So we gave this kind of explanations to the authorities as well, so that they know that these are not something in air. It has a profound impact on how building works and how the energy consumption works, and at the same time the well-being in the outdoor conditions. Similarly, for different materials as well, we give an explanation. I think we are exceeding the time, so I'll just skip some of the slides. These are some visuals from the presentations made to different stakeholders during the presentation during the designation time. And if somebody is interested to know more about the project, I've just put up the link here. You can take it up. And with this, I'll stop here. And if there are any questions, I'll be happy to answer. Thank you.
Yeah. Thank you, sir. It was a very exhaustive presentation. And thank you for accommodating our request in spite of being under the weather. And so I think most of our attendees are students. And for them, even if they find it technical, I think it really works well because we got to see the project entirely from the conceptualization to the methods to the results till how the strategies are figured out. And even for all the PhD scholars who have joined us, we understand the amount of rigor that is needed in a research project. Thank you for that. Questions? We are open for questions, and you can unmute yourself and please ask.
Hello, sir. Am I audible?
Yes, you are.
Yeah. Hello, sir. Thank you for your information. Like, it's a fantastic presentation. Like, I have a few questions. Like, the first one is like, how do we do a LCZ, like local climate zones? So, how do we like? Is there any tool to come up with LCZs?
So you're muted. You're muted.
Got it. Yeah. Yes, sir. There are tools available. there is a tool called UDAP that is specifically made for generating LCZ. We can also use GIS to do this exercise. UDAP, WDAPT, UDAP tool. And it works on it works similar to your LCZ classification. We have to give training samples, and then based on the training sample using machine learning technique, it categorizes your city into different climate zones. And I think I have a.
Thank you, sir. I have one more.
I can.
I have one more last question. So,
Yeah.
permit me.
Just 1 second.
It's regarding NVMet, sir. Yeah.
Yeah. For example, you can see my screen, right? Can you see my screen?
Yes, sir. Yeah.
So, for example, this is a pre-classification of LCZ. These are called training samples. We have to, for example, let's say, just for explanation purpose, the white polygon lines that you see, I'm just saying it as compact mid-rise. So we have to have an understanding of the city and then give these training samples to the system. And these training samples will help the system to generate some similar polygons. So it works on a similar concept of your LCZ, LULC classification. Similar thing works here as well. And you can do it using UDAP, and also you can use do this using your GIS as well.
Thank you, sir. One more question. Like it's regarding NVMet. Like in your case, you have used 30 square meter zone area. But if I want to use for an entire city, so is it possible? Like what will be the?
We have used 40,000 square meters, sir. Maybe you read what it was, 40,000 square meters. Can we do for entire city? Yes and no. Yes. In fact, we could have also done. One of the issue is it will take ages. We need supercomputer to do that. So, and also NVMet is for a smaller neighborhood level study, not for pan city level. So we need different, you can do it maybe, let's say let's say you're doing for Bangalore, maybe you take 10 representative, 10 maybe small, maybe let's say some 20 representative neighborhoods, and then you can study. Pan India, pan city assessment using NVMet, I think it will take maybe years for completing simulations.
Is there any other alternative tool like freeware
No.
instead of NVMet, sir?
No. At the moment, no. Maybe we may get soon something. Yeah.
We have a couple of questions in the chat box. So I think somebody is asking how the 3Ds for the neighborhoods were made. It's a question from the chat, please.
3Ds from the field investigation. We have documented what is the height by field investigation, and this has been taken to NVMet for modeling. If you are asking how did we get the height information is taken from the field investigation, and we have the base map. 2D drawings were already there. We wanted confirmation for height, so we did field measurement for getting heights.
And I think there's also another question on the tools, but it doesn't specify. If you could elaborate on the tools further, I think they can go and see the project
on identifying LCZ and tools. For doing LCZ assessment, you can use UDAP and you can use a GIS as well for LCZ classification exercise. And other tools, there are other tools also. For example, let's say, I am slightly answering to Murliji's question. Do we have alternate tool? Yeah, we have an alternate tool as well. For example, let's say we have a tool called, it's all free version only, where you can generate PET UTC as well. I'll recollect and tell you, but there are few tools where you can Rayman Pro, for example, Raymond Pro can be used for generating PET, UTCI, and it's a free version, free tool. You don't need a license, but for a smaller area. So why we are saying NVMe? Because it is more accepted in scientific community and it's commercially available. So we are using that. So otherwise you can use that as well. And then we have something called urban weather generator as well. You can use that as well for running simulations. That is also available. And how were VD neighborhood develop? What measurement tools were used? No, we did not use any tools for getting the height since we were working closely with the local government. So we had access to the building 2D data and also height information. Can we have results for energy consumption, electricity data, EUI from NVMet? No, NVMet does not simulate energy assessment, but you can do that in GIS, and EUI you can do it in as on date you can do it in NVMet. Maybe it is just adding of a few more columns. They may do it in no time. As on date, no.
Sir, I have a question, if I may.
Yeah.
So regarding all the base case comparisons that were done, and initially we had you had taken the focus on the summer months. So was the tests also done to understand if in the winters the temperatures dropped below the comfort zone?
No, we have not done that. This is done only during the summer months.
So if at all it has an impact which makes the winter more chilled to survive outdoors, then what would be your take on it?
That's a good question. Actually, Hyderabad is composite climate. They have equally severe winters, but we have not tested the results with respect to cold conditions. Maybe only no, we don't have any data for winter. So I'm not sure whether it will create more discomfort because of this material. I may have to check.
Sir, if I may continue this question in a different thread. So every city here, mostly metropolitan and urban dense areas, have an UH intensity. So in order to mitigate it, it's most probable these similar strategies that either are used at different intensities based on the city and its density. So
Right.
if you have to select a field area, how would you narrow it down on a national level that which city needs this the most? So do we look only at the summer months, or we let go the cities that have high humidity and monsoons is not an issue in those cities? So somewhere on these lines, I hope I could say it a bit better.
Okay. No. For example, after this project, we had in fact put up for one more proposal where we are trying to do pan-India study. Pan-India means not for the entire India. We have taken a cold climate as one of the study, Delhi as one of the study area. Like you can see we have cut India north south and east west. North we thought of taking a cold climate as one of the study, Delhi, then Madhya Pradesh, Bhopal, then Hyderabad, Bangalore. On the y-axis, we have put Ahmedabad, one more, forgetting the city, and Kolkata. And on the coast, we have taken few cities. To answer this question, can we have generalized understanding? That is the study itself. We can't have generalized strategy. It is not working. Even with the study, it is not working. So it has to be micro in the sense neighborhood level or urban level study has to be done to check whether these strategies are going to work. And also this has been supported by other arguments as well. We had a workshop during the project time, and in that one of the professors who's an expert on the field, I said he also said a similar thing. This there is a word I'm forgetting. we can't use, for example, let's say it worked in Singapore, it works here. That's not going to be the case. And same applies for cities as well. It worked in Hyderabad, it will work in Bangalore. No, it will not. We don't know. We have to test it.
Sure, sir. Thank you so much.
Sir, I have a question. This is regarding NVMed software. If I'm not wrong, this is not a free software which is actually available. So how do we access this software? Is there any workshop which is being conducted wherein this will be dealt with?
Yeah, we do a lot of workshop on NVMed through the center as well, SPA Vijayawada, and also through this Amrut program. We do on and off. We do several programs. You can, if you want to learn, you can participate. Otherwise, also there are a lot of online courses as well. You can take it up. Whether you can access the software, that is a difficult question. You can still use NVMed as a trial version. Only issue is you will not be able to model anything more than 40 grid.
Okay.
Grid size is restricted, and results are also, I showed right in my slide. You can do
Yes.
about 50 odd simulations, parameters can be simulated. But in trial version, you are limited to some about 5 or 10 parameters only. If you will not be able to do PET, you will not be able to do PET and UTCI, but you can still do PMV, PPD in trial version also.
Okay. Sir, I'll get in touch with you, sir, personally, so that I'll need more assistance on this.
Yeah. Whether the simulated data validated like surface temperature by, yes, we did do. That's why we have taken the instruments, field instruments as well. We have a mobile weather station with us. We have taken to the site just to make sure the results are grounded. And is it matching with the simulation? Yes, there are some errors. The readings has to be read with those errors. It's not, let's say, for example, in simulation it showed 30. In real time it may not be 30, maybe 31, 32. So that much validation has been done. Whether our results are too much exaggerated or too undermined, no. It's within the acceptable error percentage.
I think Director Ma'am has also joined us. Ma'am, are you there with us?
Yeah. Just
Hello.
one second.
Hello?
Hello.
Hello, ma'am? Yes, ma'am.
You can hear me, right?
Yeah. There's a little disturbance, but yeah, final word from
Yeah,
you.
yeah. I'm sure you will have a disturbance, but Faiz, I'm so sorry. I couldn't see your all the presentation, but definitely all the participants must have enjoyed. I'm sure about it. But I want to go through the YouTube. I'm sure today it will be uploaded, so we'll go through it, and then I will call you, and then I will say how was the session.
Thank you so much.
But I want to thank you so much, Faiz. The short notice you accepted. But what I felt is like, I want to call you to college also, where you can conduct at least a 2 days workshop or something where kind of a simulation can be done properly.
Yeah. No, I'll be happy to do, ma'am. Yes, ma'am.
Yeah. Because the students now working on SDIs and all that, so they may have some limitation in terms of the simulation. And I think one of the semester they completely work on a simulation itself.
Okay.
So which will be helpful. So definitely I will request our faculties to be in touch with you for conducting a workshop.
Okay, sure.
Okay.
Sure.
And I've seen like a lot of questions, and participants are actively asking so many questions. Definitely they must have liked the presentation.
Okay, good. Thank you.
Thank you so much, Faiz. Thank you.
Thank you, ma'am. Thank you so much.
Yeah.
Just one last question. There were not several instruments. We have only one mobile weather stations. We have taken only one mobile weather station for recording. And If you have listened to me, they already have 155 weather stations locally there. So we don't need any further validation of that. So we purchase those real-time data. Every hour they are recording it. So we took that data to validate it. In addition to that, we just took our own mobile weather station data to check whether there is a variation in our data versus this automatic weather station data. So we have about 17 weather stations local data that were also used for validation purpose.
Any other questions from participants? So again, thank you. Thank you for joining us.
Thank you.
I'll just quickly check I think we've answered all the questions in the chat box as well. Thank you, sir, again, for a wonderful session. And thank you to all the participants for joining us. Do continue to encourage us by joining for all our future research dialogue seminar series. Thank you so much.
Thank you. Thank you so much. Yeah.